The question says what volume in milliliter at STP of sulfur dioxide gas is oxidized by 100 ml of 0.1 molar H2Cr2O7 in acid solution. Reaction is taking place in acidic medium. Now pay attention carefully. First of all, we write down the chemical reaction. Okay, we have H2 and Cr2O7 is there. Okay, and this is what is strong oxidizing agent. Why? Because Cr is present in its highest oxidation number. Okay, and since the reaction is taking place in acidic medium, it will always convert into Cr3 plus. Remember. Okay, and sulfur dioxide is reacting with a strong oxidizing agent, then definitely it will undergo oxidation reaction. It will undergo oxidation reaction, and there will be increase in its oxidation number. This is what sulfur dioxide. In this case, you can see, in this case sulfur dioxide, sulfur is present in +4 oxidation number. Means whatever the product is coming here related to the sulfur, in that product sulfur will be present in its highest oxidation number. Then common sulfate, we can get sulfate, and this is what SO4 2 minus is there. Reaction is complete. Okay, because in sulfate and 4,2-8 -2 is there, sulfur is present in +6 oxidation number. You can see if you compare the oxidation number +4 to +6, increase in oxidation number, and we have learned increase in oxidation number is always oxidation reaction, and decrease in oxidation number is always reduction reaction. Very interesting part. Okay, so sulfur dioxide is undergoing oxidation in the presence of strong oxidizing agent, converting into what? Sulfate ion, and this substance in acidic medium always convert into Cr3 plus, undergoing reduction reaction because it is what? Strong oxidizing agent. Now let's balance this equation. First of all, we write down the oxidation number. For this already written, this side also written. For this, for Cr we can calculate 7 2 is 14, hydrogen is what? +1. Then in this case +12 will be there. 2 Cr is equal to +12, then 1 Cr is equal to +6 is there. Okay, if you balance this equation, but I think we can apply the concept of milli-equivalence because volume as well as molarity is given there. So we do one thing, very interesting part. Number of milli-equivalence of this substance is equal to number of milli-equivalence of this substance, and by using this concept we can calculate the moles of sulfur dioxide, and once we calculate moles at STP, we can convert easily into liters. Liter, yeah, ml. Okay, so the concept, we have number of milli-equivalence. The formula is what? Number of milli-equivalence. Number of milli-equivalence is equal to first we have millimoles multiplied by n factors, and next we have molarity multiplied by volume in ml and multiplied by n factor is there. Okay, means the equation is ready and we can calculate n factor value, and then we can apply this formula. Very interesting. Okay, n factor is what? Difference in oxidation number +4, other side +6, difference 6 minus 4 is equal to 2, and factor value for the sulfur dioxide is ready, that is what? 2. In this case, always balance the number of atoms before balancing the charge. 2 Cr, other side 1 Cr multiplied by 2. 1 Cr is what? +6, then 2 Cr will be present in +12 oxidation number. 1 Cr +3, then 2 Cr will be present in +6 oxidation number. Find the difference in oxidation number. 12 minus 6 is equal to, we got 6. So n factor value for H2Cr2O7 is equal to what? 6. Very interesting. Now we can apply the concept of milli-equivalence. Okay, number of milli-equivalence, we have number of milli-equivalence of H2Cr2O7 is equal to number of milli-equivalence of sulfur dioxide is there. Okay, in case of H2Cr2O7, the data is given volume, molarity, and n factor already calculated. So we apply this formula: molarity multiplied by volume multiplied by n factor. So molarity is what? 0.1. Very interesting. 0.1 is given there, 0.1, and volume is given there 100 ml, and what is the n factor value we calculated? That is 6 is equal to other side. Now keep in mind, we have to calculate the moles of sulfur dioxide. So I apply this formula because molarity is not given for sulfur dioxide. So millimoles is equal to n factor, and always keep in mind 1 millimole is equal to 1000. 1 millimole is equal to 1000 moles. 1000 mole. Directly I am writing here 1000 moles. 1000 multiplied by mole, and then n factor. What is the n factor value for sulfur dioxide? That is 2. We already calculated. Now we can simplify. Pay attention carefully. We have 2, this 2 3 6 will be there, and we got mole is equal to this will be 10 multiplied by 3 divided by 1000. Why? Because this decimal is there, so 10 will eliminate. Okay, 0 will cancel, then 3 upon 100 is there, and this is equal to 0.03 is there. Okay, these are the moles we got, moles of sulfur dioxide. Now if at STP we have learned at STP we have learned 1 mole is equal to 22.4 liter, and we have to find the answer in milliliters. Yes, in milliliter. So we have 1 mole is equal to 22.4 liter, answer it is also equal to 22 and 400 ml is there. If 1 mole is equal to 22,400 ml, then 0.03 moles is equal to how many ml is there? Okay, so we have the volume of sulfur dioxide. We can calculate volume of sulfur dioxide. We have volume of sulfur dioxide in ml is equal to how many moles we got? Is 0.03 mole is there, and 1 mole is equal to 22.400 ml and divided by what? 1 mole is there. Mole will cancel. Okay, if you remove the decimal, these 2 0 will eliminate. 3 4 are 12, 3 2 are 6, and 7 3 2 are 6. 672 ml is there. This is the volume of sulfur dioxide. The very interesting question. Any option given here, you can see we have option A is there. Option A is correct. 672 ml, this much volume of sulfur dioxide will be oxidized by the strong oxidizing agent in acidic solution.